In order to discuss how to add dimensions and constraints to sketch entities, which control sketch element sizes and relations, it is important to discuss them in the context of what is called design intent. Design intent is a strategy where geometry is defined in such a way that changes produce desired, predictable results. Let's take a look at how design intent comes into play with something as simple as two vertical lines. These lines currently have different lengths, and there are a number of methods that can be used to make them the same length. One way is to define each of their lengths using two separate dimensions. These dimensions must be updated independently. Alternatively, I could still use two dimensions, but create a reference for the second dimension to link back to the first so that they are equal. This causes the lines to update simultaneously, and their lengths are both explicitly defined. Or, instead of using two dimensions, I could use a single dimension and an equal constraint to make them the same size. This causes both lines to update simultaneously, but only one length is explicitly defined. In all three scenarios, the lengths of the lines are the same, but they will update differently since they are defined differently, as you'll also see in the next sketch profile. These three identical sketch profiles are good examples of how design intent impacts an update to the sketch. They all currently have identical geometry. However, there is one major difference between each of them. The first profile has its center line defined to be 50 millimeters from the left edge. The second profile has its center line defined as 50 millimeters from the right edge. The third profile uses a midpoint constraint instead of a dimension, which keeps the center line connected at the midpoint of the bottom edge. The design intent for each is different, and if I update the 100 millimeter edge on the bottom, the geometry of each will change. In the first profile, changing the bottom edge to 125 millimeters shifts the upper part of the sketch to the left, keeping its 50 millimeter position from the left. The second profile shifts the upper sketch geometry to the right, keeping its 50 millimeter position from the right edge. The third profile keeps the upper sketch geometry centered above the bottom edge, due to applying the midpoint constraint to the vertical construction line and the bottom edge. Even though each of these profiles originally started with the same geometry, each updated differently. This makes it extremely important to apply dimensions and constraints so that they correspond with the design intent in order to produce predictable results when changes are made.